The previous videos in this series all dealt with sending commands from a GUI on the PC to control devices connected to an Arduino board. We made servo motors turn and lit up LEDs to varying levels of brightness. But that is only half of the capabilities we want to explore. Having information sent from the Arduino update controls on the GUI is the next logical step on our journey. Can we import data and commands from the Arduino to our GUI? We'll find out on today's episode of Today, we want to teach the GUI how to receive and process data from the Arduino. To do this, we will use a button on the Arduino to send a command to the GUI that will be decoded and used to increment a counter on the GUI every time the button is pushed. The first thing we have to do to prepare our GUI to receive data from the Arduino is to teach it how to listen. When we open the serial port, it does start to listen, but our form does not pay any attention to the data that's being received. There is a problem we have to overcome, however, and that is that our GUI is running in one thread and the serial port is running in another. Threads are sort of like programs in that they are independent of each other and both are running at the same time. So, we need to find a way to build a bridge between the two threads to pass the information. That is a job of a thing called a delegate. We will create a delegate at the class level of our GUI and use it in our listening function later. So click on the Code tab and go to the top of the class, clicking right behind the variable red that we added last video, and create the delegate by typing public delegate void, and we'll call this D1 is the delegates that we are going to define, and then we will use string data called indata to send to it for information. So that is the bridge that we need between the two threads. Now, for our GUI, we'll need to create another variable which will just be a private static integer called counter that will hold the data indicating the number of times that the button has been pushed since the program started running. That will be displayed on our form. Now we will create the data bridge in the serial port thread by using a function that is called every time the serial port receives new data. Our function will save the data and then call another function running in the GUI thread to decode and process that data. So, to create the data received function, click on the Design tab, then click on the serial port control, and in the Properties window, click on the lightning bolt button to display the vents that are defined for the serial port. So we want to use the data received event, so double click on it and it will now create the stub for that function. We can now add the code to that data received function so that we can trap and store the information coming in over the serial port. So the first thing, let's just create a string called indata that is stored, in which we will store the serial port 1 data, which is a string, and that's using the function read line. So that is the read line function of serial port 1, which I misspelled, serial port 1. That takes the data and stores it. So now we can use it in our program. Now, this is where we create the instance of a bridge that we will use to transfer the data. So D1, which is our delegate, and we're going to call this instance write it, and that will be a new delegate, D1, and it will call a function we'll create later called write to form. And that will be the function in the GUI thread that will process the information that we send to it. So that's all we need to do for storing the data for processing. So the data is now visible to the GUI and it can be decoded and used. To display the push button data, we'll add a text box to the form and change its name to text box 2. So go to the form 2, bring a text box over. Text box is there's a text box. So we're going to bring a text box over. We're just going to click on the form and we will change its properties. Its properties will be, let's go up here. Its name is text box 2. Okay, so that's now on the form. Back to the code window. We will now refer to that in our new function. So immediately below the function we just added, we have to add a new function of our own making since this is not an event. This function will be called every time new data is received from the serial port. So it's a public void. It will not return any information. It's called write to form is the name of the function, just like we had above, and it will receive a string called inData. Okay, that function will open braces for the function, and now let's just put a comment there. This function handles data sent from the Arduino. Okay, let's create a character, a char called first char, and that will be analogous to the character that we stripped from the data on the Arduino board when it was received so that we can decode it as a command. So now let's create a single called numData. After creating those two variables, let's now get the information from the data we received and put it into the first char character. So we need to strip the first character off. So this is first char is equal to inData and in a bracket 0 bracket. Okay, since C strings are nothing more than arrays, we can just take the first character in that array and put it in first char. And now we'll create a switch statement just like we did on the Arduino programming for processing this first char and perhaps maybe getting the other data out of the data that was received. So switch, and we will switch on first char since that is our command indicator. Let's go ahead and add the braces. All right, let's now create a case. And the case is a lowercase p because that is what we sent as a command every time we push the button. Okay, what happens when we receive a lowercase p? Well, what we want to do is increment the counter. So we'll increment counter plus plus. And then we want to send that information to the text box for display. So we'll take the text box to.text property and set it equal to the counter, but the counter is a number, and we need a character, or we need a string actually, for the text box to text property. So we'll use the convert dot to string function, and we'll feed it the counter variable data like that. And then we will just add the break command to finish off our case. At this point, we have in place the capability to receive data from the serial port and move it over the data bridge to the GUI for use. And that's it for the C# program. Save it and move on to the Arduino program. I've added a push button to the Arduino board and connected it to channel 4. In the setup function, let's add behind the other pin mode statements, a statement to activate pin 4 or channel 4. So pin mode, we're going to set channel 4 equal to an input. Oops, I'm sorry, that needs to all be capitals. Input underscore pull up. So that we can use the push button with its internal pull-up resistor. That'll make our wiring on the board a lot easier. Since we are using a push button, we must add some sort of debouncing facility to our program. For ease of implementation, I've used a routine from Adafruit and tailored it for our needs. We will need to implement some required variables for this routine, so let's add them right now at the top of our program, right behind the other variables. Let's add an unsigned long called last debounce time and initialize it to 0. That will be the last time the output pin was toggled. Next, we need an unsigned long called debounce delay, and we're going to initialize that to 5 milliseconds. That is the debounce time that we want it to ignore any rebounces from the push of the button. So that's our time. Now we need to create an integer called button state that will hold the current reading from the input pin, and a final integer called last button state, and we'll set that to high so that it is going to keep the previous reading from the input pin, and we'll start it off high so that it will function properly the first time through the program. So the actual function to debounce the button push needs to be inserted in our program after the switch statement. Remember that the switch statement is to decode received information. The button is independent of that. A button push can happen at any time, and our trip through the loop function should be fast enough to catch it. When we get a legitimate button push, we will send it directly to the serial port. The debounce function works by beginning a timer when the button is pushed for the first time. If the button appears to be pushed again within a debounce time period, it is ignored so that only the first push is recorded. So let's make the following function after the loop function, but to save time, I will paste the complete function onto the program and then describe how it works. So if we go there and do a Control V, now you see that we have a function called handle button. Handle button is the function gets called every time through the loop that will check the button state and decide if we need to send data to the GUI or not. So here's how it works. Basically, we just look at the current state of channel 4, which is the button, and we record it. Then, in order to tell whether it has been pushed or not since the last time we went through the loop, we compare it to the last button state. If they're not equal, we know that the button's been pushed, so we start our timer. If they are equal, then nothing's happened, we just skip that. But we need to check to see if the button has been pushed within a debounce delay, which we've defined as 5 milliseconds in our program. So if it is greater than the debounce delay, that means we're through the whole debounce period and we've got a valid button push, and then we can check that to see if it's not equal to the button state, and if it's not, we just save that as reading, and then check it to see if it is a high. If the button state is a high, that means that it is currently pushed, so we want to send that data to the GUI. We do that with the serial.println function, and we send it a single P as a string. That gets the data to the GUI, and then finally in this function, we just need to remember our state by putting our reading in the last button state so that the next time through the loop it can check it and remember what that reading was. Okay, so that's the debounce function. Now we need to call the debounce function from our loop. Well, we want to call that after everything has been done in the loop, where we check for if there's serial data available and also then go through all of the switch statements. Now we'll just add this line afterwards where we invoke or call this function, and we'll just do that by calling the function name handle button and an open and close paren. So that should be it for the programming for this. We can check and see if we have a good program by compiling it. It does compile, everything is good. So we now have the capability to trap a button push and send that data to the GUI. That should be it for the Arduino. Compile it now, which we just did, and then download it to the Arduino board to run. We're almost ready to run the program, but before we do, I must add a statement to the C# program that I missed before. Click on the Code tab and go to the Data Received function. We have to add an additional line of code that will actually start the data bridge working. So position the cursor behind the right to form and then add the line invoke write it comma in data, and then end that with a semicolon. So that should be it. Now we should have a functional program. We can go back to the form design and let's take a look at how that runs with the Arduino. So let's take a look at the Arduino board, and I'm going to start the program, bring the form over, and let's resize the form a little bit so that we can see the board. We can make that a little bit bigger. Now we should be able to push on the key and or push on the button, and here in this text box we should get a count of how many times the button is pushed. So I'm going to push it once, and then again, and then again, and again, and again. I can push it very reasonably fast, and it counts it every time. So that's it. We now have the program that will transmit digital data from the Arduino board to the PC for display on the GUI. And we have one more task ahead of us that we'll cover in the next section, or the next video. And that will be transmitting analog data from the Arduino to display on the GUI. So until then, thanks for watching.